All right, everybody, welcome to a special edition of IoT Coffee Talk. Tonight, we got Roger Pena here, and this guy is one of the leading thought leaders in the world of IoT, and he's going to tell
I
us
wouldn't say
his.
that.
Don't be bashful. We know you're awesome,
I'm
dude.
just different. That's all. I'm just different.
That's good. The world needs different, doesn't it? Um,
Yeah,
and
yeah.
so, yeah, he's gonna share with us the kind of things he's been writing about. If you're on LinkedIn, you can't help but see the kind of posts that he's doing, and he's got his view of IoT and what makes it successful and how all that, because I know we've all been bumbling and stumbling in the dark sometimes trying to make all this stuff work, and maybe we were all following the wrong path, and maybe Roger's got the right path. So how's it going, man? Good to see you in
It's
person.
going good, man. It's going just first good to meet you. It's good to meet you. I see a lot of your stuff online. So
Heck yeah.
likewise, I follow your stuff and you post a lot on LinkedIn too.
Lots of little things.
Yeah. So about me, how I got into this,
Yeah.
like I have no little background to this at all. No academics, no I never knew what IoT was at all. Um, but I knew the concept of like a smart home,
Yeah.
right? And I got out the Navy just like you and started school, took a couple computer networking classes, but it had nothing to do with what I was trying to go for.
Yeah.
And then I ended up buying my first home, which I got it built, right? So I
Ah,
got it built and I started thinking about like what I want to put in it. You know how you think about furniture and stuff like
yeah.
that,
Right.
right? So I started thinking, oh, well, I want to make my home this way. And well, I want my home to do things for me,
Yeah.
right? That's how I started thinking about it. I was like, well, what's out on the market? And I started thinking about, well, I think I can add this and this will help me out, benefit me in some kind of way. I was like, well, what if I want to add something else? And then I want to add something else at a future tense.
Yeah.
And I started thinking about that. Well, how do I go about that? You start researching like, okay, well, what's what? Wi-Fi, what are the technologies out there? What connects what? Is there anything that will connect all this together where
Yeah.
it's easy for me, where it's not complicated, where it gets real complicated and stuff?
Right.
And that's how I started, like researching it. And then I was like, hold up, there's nothing out there that does that. I
Right.
was like, there's nothing out there that does that. Like, I mean, I'm gonna live in this home probably for like 10 years and add things into the home over that time frame,
Yeah.
like energy efficiency stuff like
Right.
that.
Yeah.
And I was like, well, that means there's a problem to the market. So I'm like, okay, there's got to be something out there. There's got to be something out there.
Yeah.
And then you start seeing like these standards, and then you start seeing the alliances between these things, and all these variations. And you're like, okay, well, what is the actual best technology that can do all this stuff,
Right. Yeah.
right? You start thinking about, oh, so you start researching this technology, this other technology, another technology. Well, they all have their merits.
Yeah.
They all have their merits for specific use cases. There is no single best technology. I'm like, oh, so dang, it's going to be complicated.
Right.
Like, well, how do I make that process as simple as possible? And that's when I got an idea. I was like, huh. I started thinking about it. Okay, well, let me look further, see if anything fits the matching what I'm thinking about. And as you keep doing the research, you start seeing that term, you start seeing these technologies and you get a little bit of understanding of the technology. Like I don't understand it to the level of which the way you understand it, but you start seeing the term IoT,
Right.
right?
Yeah.
And I'm like, well, what the heck is IoT? What does that got to do with the smart home? I
Right.
have no idea what that has to do with the smart home. And then you start going into the reports and you see these projections, IoT, these huge masses of 50 billion connections by
Yeah.
year X and yada yada and all. I'm like, wait, hold on. What does that got to do with the smart home? I'm like, you're seeing the information like
Yeah.
this technology fits in a smart building. Like, oh, okay, well, let me research the smart building.
Right.
Because maybe there's something there in the smart building that can translate to, your smart home.
Yeah.
So you start seeing this stuff, and then you're like, okay, well, what's the picture of actually what I'm trying to do? Let me do some further research. I think the first, I don't know if you ever heard of this. They changed the name, but it was called CABA, Continental Automation Building Associate.
Oh,
This
okay.
was a
Oh,
long time ago. Yeah, and they did like it was like a research firm, and they put out a lot of reports, a little bit on the smart home, but a lot on industrial stuff.
yeah.
Like, so now I started learning the perspective of industrial consumer,
Right.
well, smart home.
Yeah. Yeah.
And then, so I just kept doing research. And then I was like, okay, well, let me see if there's anything in patent terms that, okay, what am I thinking about here? You start looking through, like doing a little bit of research on patent, just see how your idea might fit into a patent term.
Yeah.
I was like, okay, well, this process patent kind of defines if you put A plus B plus C, then you get a result of D, and
Yeah.
that's provable, right? And that's
Right.
kind of a process patent. I said, okay, well, that's kind of like the way I think about it. So I was okay, let me keep I started engorging myself with the research and trying to
Yeah.
learn exactly what it is that I'm talking about,
Right.
right? So I know I'm talking about a smart home and the scale of the smart home, right? Scaling the ecosystem,
Yeah.
based on what I want to do and at a simplified manner,
Right. Right.
right? It's got
Yeah.
to be simple because I'm like just a normal customer, right?
Sure.
So I started thinking about that. I'm like, okay, well, how do you how do you articulate that?
Yeah.
How do you so
Yeah.
I'm like, you
Yeah.
keep researching, and then the the iPhone came out as I was
Right.
doing this research, right? The
Yeah.
iPhone came out, and then I saw this it was a Wired article, and it was a really good write-up about the iPhone, like
Hmm.
right when it came out. And they went in all to the whole details of the iPhone. It talked about like the technology that was in it, right?
Yeah.
And then it talked about the developers, and then it talked about the consumer and stuff like that. I
Right.
was like, oh, I see some of those technologies in there. I was like, hold on, those things go into these products that are in the home,
Yeah.
because I've seen it before.
Right.
I'm like, well, maybe they're the kind of same market,
Hmm.
structurally.
Yeah.
And then so I was like, okay, well, there's a comparison of the way you should think of the smart home. And
Yeah.
that's how I learned to articulate. And you see it in my writings
Yeah.
about
Absolutely.
when I compare, I always use the smartphone as the analogy to what the potential the smart home can produce. Right?
Absolutely.
I always yeah, I
You
use
know,
it and then
I was just sitting there thinking, if it wasn't for the iPhone and Android and BlackBerry and Windows, the whole smartphone revolution, I don't know that we would have IoT today like we do because all those tiny sensors and MIMs and
hmm
they were
hmm
horribly expensive, but the smartphone revolution caused, they said, we have a demand for these tiny things that go in this phone, which to your point, they also are IoT things. And it helped drive down the cost and created mass production of all these
correct.
sensors
Yeah.
and technologies. And yeah, I think we really owe the smartphone revolution to making it more accessible for us today. Because you can imagine, it's funny when I think of smart homes, or I think of the early days of people doing something
I've
crazy.
seen some of your podcasts,
Do you
like the General
remember?
Magic and all that.
Do you remember
I've
like
seen
there used to be these companies? It used to have to do a lot with audio equipment. Actually, the early days in a home, like if some rich person, it's like, we're going to come in there and you're going to have this high-end stereo and you're going to have speakers in each bedroom and we're
hmm
going to wire it up and you
hmm
have this control panel and it was going to
right,
be like $20,000 and it was just
correct.
crazy. And maybe we'll have you be able to turn on the lights off and on in another room.
Right, right,
And people
right,
are
right.
like, and
Well, I mean, so that just as you just saying right there, that's the problem of the smart home market today, right now. So if you want to reach that kind of level of networking within your home, that's what it costs because you need somebody, a professional integrator, to come in and mesh all that stuff together,
yeah,
match what technology doesn't match with what. And I know they have the big thing like right now about Matter.
Yeah. Yeah. Right.
interoperability.
Yeah.
I'm like, well, if you look at it this way, where you understand the technology market, it doesn't stay still. There's
Yeah.
always innovation coming.
Right.
There's all this technology that basically like the smartphone, it
Yeah.
attracts all this technology to it, right?
Right.
You know, you start out with just basically like Bluetooth and Wi-Fi and these
Yeah.
simple things, the actuators, the
Hmm.
GPS, now look what it has in it today,
Yeah.
because it's cracked it all those things into it, right? So that's the market. That's like one side of the market that you have to think about.
Right.
All this is coming to this side of the market, and then you have the consumer buying all this, and
Yeah.
it's all packaged in this complex platform that you know that absorbs all that complexity.
Right.
So therefore, you just buy it one time.
At one
You don't
time.
have to worry about all this stuff,
Yeah.
integrating to all this, what you're trying to do, all
Yeah.
these outcomes that this thing produces for you.
'Cause you're so
You know,
right. If the only way we got smart homes is by spending 20 grand or 50 grand on some integrator to build all this crazy stuff, that market's never going to take off. It's always going to be a handful of rich people.
right?
I think about, you talk about the iPhone and then smart homes. I think of, the guy Tony Fadell who
Yeah.
created the iPod and then he
Hmm.
helped design the iPhone and then he left Apple and he created Nest
Nest, right?
and Nest thermostat. And I remember thinking back, especially when, because there was stuff we did a long time ago and it was kind of fit for purpose and we weren't trying to build a market, we were just trying to solve a problem. And then IoT really took off like 2010 timeframe around there. And that's to your point, that's when crazy companies like Ericsson and GE said it's going to be 50 billion devices by 2020, which didn't happen.
Yeah.
And everybody, there was a hype machine. You had McKinsey Consulting saying it's going to be an $11 trillion market. And as soon as they heard that, every company in the world just dove in because I
Right.
want to get
Jumped in there.
that big bag of cash, you know?
Hmm.
But I feel like the ones that have been most successful actually just built some simple product. They weren't trying to do like a lot of times in IoT, it's like, oh, I got this platform and I'm going to build all this stuff. But the ones who've been successful, like Nest Thermostat, he took a lot of complex things, Tony did, and because I remember when I bought our first Nest, and it was like simple IKEA instructions, how to unscrew your normal old school
Hmm.
thermostat
You
on
get
the
the little
wall.
screwdriver, and yeah,
Yeah,
it gets all
everything.
these steps. Yeah.
Absolutely. And it's
So,
like it's got to be that easy.
so what the actual smart home today is, this is the way I always say it. There is no actually smart home market. There is just a market of smart devices,
Yeah. Yeah.
individual smart devices. That's all it is, right?
Yeah.
So, still nothing works together. I know Matter's trying to work on that, like the interoperability,
Right.
but
Right.
I'm not to me, I'm not a standards guy. I don't believe a standard will work out.
I'm so
This is
glad you said that. I'm so glad you said that. I love
no,
that.
I'll stand on that. Like
Yeah. No, I remember
it's easy. It's actually easy to prove just
it
based off,
is. It
you
is.
know, all the technology that's coming to the market. It's like you're gonna tell the consumer, well, you can't buy that. That doesn't comply with the Matter
Right.
protocol. You just can't put that in your home. And then, Matter only does like, okay, well, they communicate. Okay, well, what happens if the communication fails or something goes wrong with the problem? I mean, the product, who's responsible for that? Who owns that?
Right. Right.
Nobody. I mean, the consumer, it's on the consumer,
Yeah.
there's
We've seen
nothing
a
in
lot of
place.
we've seen a lot of horror stories where people paid a lot of money for their IoT doorbell or whatever, and then the company goes out of business and it was connected to a
Correct.
cloud, and now the cloud's
Yeah.
gone and it doesn't work anymore.
Right, right,
And
right.
yeah, all these subscription-based things, and they're stuck with this dead thing. Or I think of another specific product like the Ring doorbell. That was a success. There was a bunch of things, and you're right. It's not a smart home. It's just a bunch of devices. We saw companies try to pull that together at different times. I
Hmm.
remember
Hmm.
early on, remember Samsung did
Yeah.
smart things.
Yeah.
Um, and so
Well, they're
Samsung
part
was,
of the matter deal. They're part of the
yeah,
matter deal.
yeah. And so they were trying to pull things together with their stuff. Obviously, Apple has tried to do it with not much success at all. Amazon has tried to
Google.
pull things together. Uh,
Microsoft actually try to start it early, before Amazon ever came about, Google ever came about. They did like pilots.
yeah,
I've read this a long time ago. Like I
yeah,
think this was the first things I read about, smart home were when Gates was
yeah, yeah,
CEO. He
right.
tried it, as small,
Yeah, you're
he
right.
didn't
Back,
ever.
remember back in the 90s, there was all this written about when he built his house, when
Right.
Gates
That was it. That
on the
was, yeah,
lake.
that was it. Yeah,
And they're
yeah, there
like,
you
this
go.
is the most futuristic, high-tech house on the planet. The art on the wall would change depending on,
And
just
nothing ever came of it.
yeah.
Nothing ever came of it.
But I do remember like when we were building Azure IT, and I remember there were people in the earlier days of just this IoT craze, starting in the 2010s, where there were people who said, you know what, we're not going to get involved in this until someone figures out the standard. And I just remember going, well, don't hold your breath,
Right.
because
Yes.
if you wait for the standard, you're going to miss the whole tidal wave, this whole
Hmm.
revolution that's happening. And it became apparent to me, like when we were building Azure IoT, it's like you have to support all the standards. It turns out there's already hundreds or thousands of different standards
And
for,
there'll be another standard coming along,
yeah. And so
right?
the only way we could be successful is we needed to support everything. And it was a pain in the ass, wire protocols. You need to support MQTT, and we supported AMQP and like REST, just web stuff. And then when you go into factories, you've got all this equipment and it's a whole other world with hundreds of other things. And everybody goes, oh, they need to standardize. I'm like, no, every one of those machines has their protocol is actually based on a like an IEEE or whatever standard. It's real.
Hmm.
You
Hmm.
have to bend to them if you want to play ball. And so I definitely remember the early days of edge computing where it was almost like I'm just going to put this little box like almost like remember when Intel made those little Nook devices, little tiny PC. Anyway,
Okay.
and with a lot of like serial ports and stuff to talk to
Okay.
PLCs and weird machines, and they communicated some bizarre way, BACnet, Modbus, whatever. And it's like if you want to play ball there, you have to talk that talk. And so you might talk Modbus here at the edge to an industrial machine, or like if it's a smart home or a smart building, you want to talk to the HVAC system. What's the it's not is it BACnet? Yeah, it's BACnet that uses for HVAC and those kind of things in buildings. And you talk to it that way, but then you might convert that weird protocol and the data format that might come across looking strange into something that the rest of your system can understand, like maybe JSON format or whatever, and get it into a
Mhm.
database. But yeah, it became really clear you have to figure, there was all these people that were excited about IoT and they would go in and talk to these customers and they'd say, what I really need you to do is rip out all this old stuff and put in all this new tech and it's going to be great. And the customer would say, I need you to get the hell out of my office. Because we're not going to do that. And so you have a
Right.
lot of people that thought IoT was going to be a bunch of Raspberry Pis and,
Right. Right.
and
Right.
things
Right.
hanging
Right.
off of it. And it didn't work out for those guys. And it became apparent to me over time. It's like, if you want to succeed in this world, you've got to get your hands dirty and you have to go after these brownfield projects, at least in the industrial world or whatever, or
Was it
smart
gonna
building.
like start somewhere? Is that what you're saying? Start somewhere?
You have to embrace the ugly, as my good friend Bill Pugh would say on Coffee Talk, or the gap of the ugly is where he has success, as he says. He lives up in Dripping Springs, actually. Um,
Okay.
and so you have to go after the stuff that you don't want to do. You have to, it's complicated, it's old, but the only way to have success is you need to go work with the stuff that people already have. And so it
Right.
may not be futuristic or pristine or nice or work the way you want it to. You've got to figure out how to work with it to be successful. That was a hard lesson to learn over years in IoT. You really got to embrace brownfield existing solutions, no matter what they look like. Because most people say, oh, I'm not going to do that. That's too hard. They want
Right.
something
Right.
brand new, fresh, that they create the whole thing themselves. Well, of course that's easier because you're controlling everything. But the
Right.
world's
So,
not world's messy, right?
right.
It's like being
So,
on a ship.
so getting back to the, yeah. So getting back to like we're talking about like things coming together and
Yeah,
working together and how difficult it is and stuff like that. So the way I was thinking about it wasn't like, okay, it was about scaling, right? The whole like if you have your own ecosystem, you want to be able to scale it, right? So I was researching like different angles and all this stuff, and I came across this article, which leads me into the way I tie network effects, that
yeah,
concept of network effects. So
right.
I came across this article. I think it was in Business Weekly, and it was about the iPhone,
Yeah.
right? So this guy, he was a professor. He's a professor at Boston University, and his name is Marshall Van Alstein or Alstein,
Okay.
and it had this poster at the title of the article, a Radio Shack poster, right? It was
Awesome.
a Radio Shack poster, and it
Okay.
had all the products that Radio Shack sells: the cassette player, the video recorder, microphone, and
Yeah.
tape deck, and all these things. It had all, and then in the article, it started going about, see, this is what the actual iPhone did. It reduced the cost and complexity of having all these things together
Right.
and doing all these things. And I was like, wow, wait, that's
That's
a
right.
novel way to
Yeah.
say it. And
Yeah.
then he started going into like the details of why the iPhone works. Like he talked about, okay, he talked about it from two sides. You got this technology side and you got the consumer side. Bringing that together is complex, right? If you're bringing all this stuff together, and then you have the developers, attracting all these developers to this singular, you know, technological platform, right?
Yeah.
He's like, and then he started labeling like feedback loops and why this and why it scales and why the iPhone came so successful. I
Right.
was like, wow, that's kind of what I'm thinking, like
Yeah.
how do
Yeah.
you bring the markets together seamlessly where it scales,
Right.
right? And he labeled it as a network effect.
Yeah.
And I was like, okay, well, let me start looking into his stuff, what he talks about.
Yeah.
Maybe he might mention IoT,
Right. You
maybe he
never know.
might, right? And how does that fit?
Yeah.
So as I started looking through his material, I was like, okay, well, he has a book with two other authors. It's called Platform Revolutions.
Okay.
I think I posted it over there on LinkedIn. Yeah, so I was like, I first opened the book before I was reading this book, I was reading another book. And I was like, okay, I'm gonna tap into this platform revolution a little bit later because I was looking just briefly. I was like, man, this is complex. The concept and the way he's teaching, I was like,
Yeah.
I don't understand that stuff. I was like,
Right.
I'm gonna get into it. I'm gonna dive into it. I'm gonna go really into it. Uh, but what helped me transfer how to understand that book was, have you ever read the book Good to Great by Jim
Yes.
Collins?
Yeah. It's been a long
Okay.
time. Yeah.
Okay. It mentions the flywheel,
The flywheel.
right?
Right.
The
Yeah.
flywheel. And it gives the example of Amazon, right? The flywheel and all that. What he teaches in that book kind of translate over to this network effects. And it
Yeah.
has to do with the flywheel.
Yeah.
Like you're trying to get feedback loops to reinforce what it is that you're trying to do business wise,
Right.
right? To scale the business, right?
Yeah.
So this platform book, when I started reading, it started going into about the history of the internet, the dot com,
Yeah.
before the dot com, right?
Right.
What
Right.
happened with the market? Why did all these companies fail? These internet companies. The
Yeah.
internet was so open, anybody should be able to jump on it and make money,
Right.
right?
Yeah.
Okay, well, why did they all fail? What happened? Okay, which company succeeded. Let's study what happened there. And
Right.
then they started seeing the patterns, like what you say, which are the agriculture and these
Mhm.
patterns.
Yeah.
You need this, and this
Right.
ingredient. So what they did, pulled, they studied it, pulled data. This is why it succeeded, yada yada, and they did it for each and every, like Google, why you do search, Amazon, I think YouTube got successful.
Yeah. Right.
Which companies just, and
Yeah.
they became like these dominant,
Right.
companies on the
Right.
internet. And you start reading the information, you're like, wow, those principles, if you actually apply those principles to IoT or the smart home, you can really do something with that.
Yeah.
You can really, like, all these projections that were projected, like the whole trillion, 11 trillion, that can be real. Like if
It
you
could be.
just know how to apply it. Yeah, if
Yeah.
you just know how to apply it, those lessons that is in there, you know, the way then I started realizing, I was like, well, you start reading the materials and then you read other materials that people are putting out in the same context of network effects. They each have their own context and little clues of this and that and how it fits, right?
Yeah.
Everything's a little bit, but it fits the core of scaling.
Right.
You have the
Right.
exponential scale, right?
Yeah.
Okay.
Yeah.
So
Did you ever read
you're
about,
like, okay,
did you ever read about or hear who came up with the term network effects? The guy who did it?
no, I know it was based off of the initial was like the Metcalf law. Like,
It's Bob Metcalf. Yeah. He invented Ethernet. Um,
right,
so remember there were all those guys at Xerox PARC where
right.
they created the first graphical computer, they created the
Mm-hmm.
mouse,
Mm-hmm.
Ethernet,
Mm-hmm.
print, all these things years before anyone even imagined that could be. And then you always hear the story about Steve Jobs getting to see all this stuff, and then
Yeah.
they think, "Oh, you copied what they did," which yeah, you kind of did.
Kind of did. Well, they let
You
him.
got
They told him to. They told him
yeah, and
to.
you
They
know,
said, take it. Yeah.
there's always interviews with Steve Jobs where he's just like, Xerox was stupid. They had the
Yeah.
most advanced technology in the world, and they were making all their money selling Xerox copy machines.
The book, the recent book they just came out with, 50 Years of Apple. It goes into really
Oh
good
yeah,
detail.
right.
There's a lot of
David
information in there.
Pogue or the guy. Yeah, yeah,
Right.
yeah. I haven't read it
There's
yet. I ordered it. I haven't read it. Um,
Yeah, there's a lot of, oh my God, there's
but
a
Bob
lot of
Metcalf,
tidbits up in there.
absolutely. But Metcalf thought about, he's a network guy. And so his law, he came out, was thinking about networks. And he said the
Mhm,
value of the
mhm.
networks is either the square or the whatever of all the nodes connected to the network. And then the
Yeah, it was
more
based off of the telephone. It was based off the telephone,
yeah,
right?
and the more nodes that connect to it, the more valuable it
Valuable it
becomes. And
comes.
it's a
Right.
network effect. Yeah.
Hmm.
And then everybody goes, ah, yeah, you're right. That could be applied to a lot of things. The flat
Right.
machine.
So what they did, they expanded that concept. Like, just they broke it down. Like, so they label that as like a direct network effect, right? And then they have uh indirect, where they call it two sides of a market,
Okay.
right? Where they feed back off of each other,
Oh yeah.
back and forth, right?
Right.
And it's based off of, so think of, it's simple. Think of Uber,
Yeah.
right? Who are the two participants of the network? The driver and the rider,
That's right.
right?
Yeah.
How do you bring those two markets together and it scales, right?
Yeah.
So that's the concept. That's kind of the concept. So when you think of that, it's like, okay, well, how does that apply to IoT, And then I started thinking about it. I was like, okay, well, most of these studies are based off of the internet, what was
Yeah.
done before, right?
Yeah.
IoT hasn't happened, right? And
Right.
it's how did the internet scale? Well, it scaled based off people using it, right?
Yeah.
You know, we learned from Google how to search.
Yep.
We learned from Amazon, how to buy stuff off from a seller, right?
Yep.
eBay, sellers and buyers, right? So
Right.
all this is basically off of people, right?
It seems
I'm
like
like,
there's a
okay,
lot of, and it seems like there's a lot of businesses when we talk about patterns that work. It's like
mhm,
matchmaking. Um,
yeah, yeah,
eBay buyer and a seller. Uber, I need a ride. You got a car, you're giving me a ride. We match us
Right.
together and we're golden. Not VRBO, whatever the other one, where you get
Well,
do
it's
that.
just okay. You find a market, and then
Yeah.
how do you scale it? Bringing these two parties together, how do
And
you scale? And
IoT,
they
IoT could be the same thing in matchmaking. There's a need, but it has to be a strong and powerful enough need, right? I'm matching. I got this service. You
it,
got this.
but see, this is where I'm like, okay, the complex part is okay. The majority of makeup of IoT will be the thing, right? The thing is networking, the machine is networking.
Yeah.
So how do you get things to network with each other, right? And then with all that complexity of, well, what technology is using, da da da, how do you match it? Da, da.
Right.
So how do you get that to happen,
Yeah.
right?
Right.
Most people like the way what I understand, people mostly understand IoT from the industrial aspect, enterprise, right?
Sure.
Because that's where it's being implemented for the
Yeah.
most part, right?
Yeah.
That's where it's. And then I started thinking, well, the way I'm thinking of it, it's not. It's more for the consumer. If you build IoT for the consumer or around the consumer, there's potentially way more use cases potentially,
Right.
right? You can build more outcomes,
That's
more
such a good point.
services,
So many people
right?
in business and technology, they think if I'm going to make it big or make a lot of money, I got to go after the enterprise. It's got to be this B2B thing. I'm not interested in consumer.
I mean, it's
But
a
Steve,
large market. It's understandable.
Yeah.
It's a large market. There's big pies to be taken out of it, but these
But
companies got to get that return on investment
But there
based
was this
off
one
of
guy who didn't believe it, and his name was Steve Jobs.
their
He's
jobs.
like,
Yeah,
consumer is so much bigger than the enterprise, it's not even close.
I'm gonna be the build the computer for the consumer, not
Yeah,
enterprise.
right,
Yeah, so
right,
yeah,
absolutely. And so how do you
so yeah.
how do you do that with IoT? What are you thinking? How do you get to that network effect? I
Well,
know you've been
you
right.
start at the to me, you start at the smart home. You
Yeah,
get that
okay,
right. You
okay.
get that right. You capture the consumer's attention
Yeah,
to using the devices, using creating their own ecosystem,
yeah,
right? Ultimately, if you find all these benefits and conveniences,
yeah,
right, you get used to it. It
right.
changes the way your living patterns, your the way you
Yeah,
live, right? Think
yeah,
about what the smartphone has done for you,
right.
right? All these options you have, it's like that's you can't live without a smartphone,
Yeah,
right? You
yeah,
can't. I mean,
right.
it's changed the way you live, the way everybody lives,
Yeah,
right?
it's
And it's
true.
created all these global opportunities, business wise, right?
Yeah,
Services, all these things. You have all these available options to you because of that platform,
right.
right? And it's orchestrating it for you, right?
Yeah,
So at the smart home level, you have like I I say this like the smart home market out of IoT market space has the most concentrated technology dedicated to it. Like trying to come into the market and fill in for all these product service needs
right.
because you have the consumer on this side who has all these variations of wants, needs, and demands,
Yes.
right? As they live in their home throughout their life. You start out as a single person. What
Yeah,
happens next? You get married. You
sure.
get a dog, you have kids, you
Yeah,
start getting old, you have all
yeah,
these variations that, you know, creates all these opportunities where if you're able to create an ecosystem around that consumer, he gets used to it.
yeah,
Okay. And then you learn stuff, you learn how they use it, what technologies they actually use, what's better, the interfaces, stuff like that. Okay, some of that stuff carries over to adjacent markets. Say your car, some of the things that are done in the smart home can transfer over to smart buildings, right?
yeah, yeah,
Stuff like that, right? And it just the that's what it becomes like a network effect around the person,
right.
right? Now, before you know it, you have more and more devices start connecting,
Yeah,
you know,
right.
based off of the consumer
Yeah,
that expands the market,
Yeah.
right?
There were probably things we saw a long time ago, like in buildings or skyscrapers or whatever, commercial buildings, that was IoT and we didn't know what it was. I remember being in these high-tech buildings and based on where the sun was in the sky, it had giant louvers on the building that would change and move. And you're like, wow, that's pretty cool. That's pretty futuristic. And really, what was it? It was sensors detecting where the sun was and an actuator that moved the louvers for light to come in the
Right,
building. It was
right,
just a
right, right,
basic IoT use case, but we
right.
didn't know that term or we didn't think like that. And then other IoT-ish things that we didn't think were IoT started happening in office buildings. Like you go into a conference room and the light turns on because there's a motion
All
detector.
right, right.
Kind of save energy, right? Electricity, and the lights go off when you're not there. Um, there's so much savings to be made, like with smart buildings, and it
Mhm.
works with
Yeah, there's a lot of use cases. Yeah. So when you think about like, okay, so why I point out there's a difference between consumer IoT and then industrial, right?
yeah,
So in one of the articles I wrote, like, okay, when you're building for a building or an industry, you're building for the purpose of that building,
yeah,
right? You know, whatever you want to make it secure, you want to make some energy efficiency to it, the maintenance of it, stuff like that.
right,
But when you're actually building for a consumer, some IoT product for a consumer, there's way more what you can do. You can
yeah,
build, right?
yeah,
Therefore, that allows you to create more data, more
right,
variation in the data versus just something that's constant. Like,
yeah,
okay, it's secure, on and off or
yeah,
whatever,
right,
stuff like that.
yeah,
So I started learning, when you start thinking about it, it's like, okay, there is a difference. Why is there a difference? When you think of it, now you're thinking of it as a network effects scale, right? You're thinking about scale. Well, what will scale more? Like if you get the market correct, it's hard to scale, say, what you implement into a building, that UCase and all those technologies. Okay, well, does that transfer to a smart city? You know, maybe
it's part of it. It's
that's
almost
part
it's
of it,
almost
right?
like when you're right, you say we don't have smart homes, we just have homes full of smart devices or whatever. And you're right.
Right.
Right now, the closest thing we have to smart cities is maybe just a collection mishmash of some smart buildings
Mishmash, right?
here,
It's just
smart,
what brings it all together.
right,
If you have a
smart
consumer,
traffic monitoring or
right? So
whatever.
if you have a consumer, um, like it's built around IoT is built around this consumer, and they're already using this stuff. There's stuff learned of patterns of the way consumers do things,
Yeah.
and those use cases, you learn the use case. Well, how do they do that, and what do they? Those things can transfer to like smart city. Okay, well, they're out going to go shop. Well,
Yeah.
maybe something can appear for them, or you know,
Yeah.
make it convenient for them, or traffic.
Yeah. Yeah.
Big traffic. Yeah,
Yeah.
it's
Oh yeah. Oh yeah. I
so.
remember thinking, I mean, just early days doing IoT, and I was trying to think of different use cases or why you needed, there was so much about predictive maintenance and IoT being the holy
Mhm.
grail of a lot of things.
Right.
And it
I've
didn't
seen
have
stuff like that.
and it didn't have to be in a factory. It could be anywhere. I was like, oh, I'm at a shopping mall and it's a two-story shopping mall. And if the escalator is out of order, a whole lot of businesses on the second floor may not have people visit them and then they're not going to make money and it's going to hurt their business. And so some people think, oh, it's no big deal. It's just, the escalator's broken. And I'm like, it might be big deal for a lot of businesses for all you know. And you can't get to it because the elevator's out of order. I know escalator's out of order. I know it sounds simple and silly, but there's like a million little things out there that IoT can give us early
So
warning
yeah.
on. We can
Hmm.
get ahead of these problems. And yet, all that being said, we've known about a whole lot of these things for a long time,
Long time.
and they haven't necessarily been embraced. I still see broken escalators everywhere, or at the airport, the walking people
Hmm.
walker
Hmm.
thing. I see those broken out of order, and it's like we have this technology that could help so many things, and we're not using it.
Right. And I always say that about IoT. Technology is not the problem to the market,
You're right.
right?
You're
It's
right.
not. It's
You're
not the
right.
problem. It's just, getting the model right, the business model right. What's the
Yeah.
business model that, you know, attracts people to actually, okay, that's the direction we need to go. We need to
Yeah.
go about it this way. You know, I'm not sure if this is a bunch of little independent, siloed, fragmented implementations.
Yeah.
Yeah, there's some successful use cases, yeah, but the one of the actually the biggest problem is ecosystem scale with IoT, scaling the ecosystem. What
Yeah.
is it that you're trying to produce? The
Yeah.
ultimate outcome, it's
No, you're right.
there's
Or sometimes I'd be talking to, depending on who you're talking to, who works at some company, and they're the ones going to write a check for this deal, whatever it is. And
Mhm.
you say, well, this new IoT solution is going to save you $1 million a year. And you think this is definitely going to be a win for me. And the guy goes, yeah, whatever. Come back to me when you can save me 10 million or whatever. Like there's
uh,
some companies that are so big, make so much money that they're like, oh, it's only that. And I kept seeing this over and over again. And I started to worry that IoT wasn't succeeding because, at least in the eyes of some people, the improvements were so incremental, at least in their eyes, that they're like, whatever, I'm
yeah,
not going to do it. Tell me when you change the world like the iPhone.
right.
I need you to
Yeah, I
move it.
mean, that's a
Yeah,
big return on investment, right?
huge.
That's a
Yeah.
huge return
They
on
want
investment. So
something big.
that's
Tell me when you come back when you got $100 million a year bang for my buck. Then we'll talk.
that's where the research of the network effects come in,
Okay.
right? Because there's a lot of little nuances in the research that it applies to IoT, but you have to have knowledge in your field. Like if you're an IoT person and you're specific, like, oh, smart building, or whatever, factories or whatever,
Yeah.
you have to know how to apply because the way when you if you ever read it, you're like, digital transformation and what does this mean? How does this apply? This has nothing to do with IoT, and it doesn't. It's just you gotta think differently, and the core concept is scaling the ecosystem, exponential scale.
Yeah.
The way they describe it, winner take all. Like that's how they
Yeah.
describe it, winner take all.
Yeah.
But in
Yeah.
reality, the way it is, it's like for when they produce these network effects, as like say Google, the result is like winner take majority of the market,
Right.
right?
Right.
So
Yeah.
that's the outcomes that they talk about.
Yeah. That's a good point. And I feel like, Microsoft and Azure IoT, when I was doing the stuff at Hitachi, my friends at AWS building their IoT stuff, GE was doing it. And in their minds, they were actually going after a winner take all thing. They wanted to beat everybody. And it
I
turns
saw
out,
the GE stuff. Yeah, I saw a
yeah,
little bit of the pre was it
that's right.
Predix.
It's
Bless you,
Predix. Yeah.
bless you, bless you.
Yeah. Thank you. Yeah, it's Predix. You're right. Um, you know, um, I learned some stuff from Predix. Predix ended up being a failure. It might have been just how they went after with GE Digital and stuff like that. But the one thing they promoted a lot, and I grabbed onto this back when I joined Hitachi, was the concept of digital twins. And
Yeah,
really
I've
grabbed
seen.
I really grabbed onto that because and so I'm like, well, how does a digital twins relate to IoT? And it's like, oh God, you're so stupid. It's integral to IoT.
Hmm.
It's the
Hmm.
thing.
Hmm.
It's not the Internet of devices, it's the Internet of things. And so the thing is the physical twin in the real world, and my
Right.
digital twin that looks exactly like it in the digital world. And I'm sending telemetry and I'm hydrating or whatever, all the properties of that thing. It could be a truck or an airplane or an escalator. And that's why we do digital twins, or a digital twin could be a collection of things. It could be all the buildings in a smart city. I mean, if I'm a, and so, you go back in time when people are modeling things, like you see all these 3D models and stuff like
Hmm.
that,
Hmm.
CAD and
Hmm.
stuff like that. And a lot of them go, this is digital twin. I'm like, it's a view of a twin. A digital twin is actually a data structure, really. And then you can
It's
have,
a simulation basically. It's like a digital representation of
yeah, Yeah.
the real world, right?
And so after a while, and so I was designing Lumada at Hitachi, I was like, digital twin technology needs to be at the core of the IoT platform because we were not terribly different than probably what Predix was doing at GE. We're at Hitachi. Hitachi was the first customer of our technology because it's a giant industrial conglomerate making bullet trains and everything else, nuclear reactors. And so it was abstracting because I remember at the time AWS had device twins. And I was like, you know what? You could do that, but really, in my world, there's the physical, whatever it is, an airplane, a car, and then it may have one or more devices on it. And each device may have one or more sensors for all kinds of things all over the car, like we really do
Hmm.
now.
Hmm.
And they're sending all that telemetry back. And you need to have a carbon copy, a digital copy of all those things on the other side. And then it makes it easier to do analytics or AI or whatever you want to do, even simple stuff. So, like in my new book, I keep it purposely simple. I keep based on KPIs, green, yellow, red. I go, well, obviously in the Navy, I remember it's like, okay, I've got green lights on this panel. We're good, or whatever.
Right. Yeah,
Or
it's basic stuff.
NASA, the astronauts. I mean,
Right.
everything we've seen in a lot of technology that got us to the moon, the indicators were either green, everything's good, don't do anything. Yellow
Yeah.
is a warning, I'm moving towards a bad condition, but I'm not there yet, and red is bad. All of a sudden, Neil Armstrong, I got a red light. I'm switching to manual on the lunar lander, and I'm going to land this thing because the automated stuff's not working. And so, like the whole book, I base it on green and yellow and red to keep it simple for people. But
Right.
I
Right. Right.
also remember what I did with digital twins. Instead of always thinking it's got to be AI or some advanced stuff, here's the example. Let's say I'm modeling a car, and the car's got four tires and it's got an engine and all these things about it that I care about. And I'll just focus on the tires. And so the digital twin of the car has all these properties. And in my mind, I'm always thinking of a class, an object in programming, an object-oriented programming. And that's kind of how I think of all that stuff. And so it has properties. The right front tire. And what do I care about? I care about the PSI, the pounds per square inch
Hmm.
of air
Hmm.
in the tire,
Right.
right? And what is the right pressure that I need? Oh, I need 32 pounds per square inch. And in other industries, people call that the set point. And so green might be between 30 and 34. And then
You're
yellow
not
might be,
familiar where you're at. Okay.
yeah. And
Yeah. Yeah.
so, and they do that. And so on the digital twin for every property, I would put green, yellow, red KPIs for every property on the digital twin. And guess what? I was just doing like Uber or Airbnb. I'm doing matchmaking. I'm doing pattern matching. I know that this needs to be 32. Data comes in from IoT, it lands in this
Hmm.
database, and I'm looking, I have a background process looking, and it goes, okay, the value for the right front tire, it should be 32. The value that came in from IoT is 39. And I looked at my little thing, and 39 is red. And so I'm going to say it's red. And then the next deal is what is the action I'm going to take? Like
Okay.
I always said at Lumada, I was like, connect, collect, analyze, act. What's the action you're going to take? The automation, whatever, right? The automation could be in the car, put on a light on the screen saying, hey, you got a flat tire or whatever.
Right. Right. Right.
But
Right.
the automation could be when I'm on the farm. The moisture sensor is now showing me that I'm down at, 20% moisture in the soil. You need and so that's red. And then red action means turn on the irrigation system. And then to not waste water, only water until because telemetry is still coming in while you're irrigating the field. As soon as it gets
Right.
back into the green, shut it off to conserve water. So I don't know. I'm always trying to keep things simple. Um,
Yeah. No, I get it. I get it. Yeah. Yeah.
yeah,
Yeah.
and I
So,
think it's a combination of things. It's like everybody's like, oh, you should just use AI and machine learning. I'm like, that's fine because you will, but the world also has this streaming stuff that happens in the moment that you can't plan for all the time. Like if you're in a self-driving car, Like you've seen all the Waymo cars in Houston now.
Hmm. Hmm.
Oh, and
Hmm.
I've been in one a few times, and
No, I haven't.
it's
No.
cool. It's cool. The first time you freak out, you're right. And
Right.
then
That's
you
what I
get,
hear the stories are. Yeah, yeah.
but there's so many sensors. That thing is so over-engineered, way more so than a Tesla is actually. And they were created by Google. And so I remember talking to someone at Google about them, and because it was Project X in Google, and then they spun it out as Waymo. They go, every car has already gone on 1 billion trips in a world digital twin world model at Google for the whole planet 1 billion times
Ah,
before it actually ever went on the road. Um, and
okay.
so and so it knows about a lot of things, but it still has sensors because a little kid might run out in front of you that you didn't prepare for in your digital twin simulation, right?
Right, 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 right,
So
right.
I feel like you need everything. I think you need machine
Yeah,
learning.
well, it is. So it's a combination of like digital twin, cloud storage,
Yeah,
APIs. I mean, a bunch of stuff, just to make something an ecosystem scale. I think digital twin is like one of the core, you know, concepts that is needed. I know I learned digital twin through reading a book, the NVIDIA. You know how NVIDIA, it's part of their DNA,
yeah,
you
yeah.
know?
That's probably
And that started from the GPU, from the just graphics cards.
yeah.
They're
Right.
about in the book, like one of the books is saying they're about to go under. They were on their last, I guess, $1 million of funding and stuff. And Jensen, he's like, we're gonna simulate this graphics shit because we need to get it out before anybody else. We're gonna put it in a digital twin. We're gonna test it, run very tests in
Yeah,
this simulation, and then we're gonna put it out. It may
yeah,
not work all the way correctly, but we're gonna put it out. And for the most part, it clunkered out a little bit, but they learned a lot just by putting it out before everybody else to
yeah.
put something on,
I
right?
mean,
And then,
yeah,
so they started repeating that process of we're going to get a product out every 6 months. And they basically created the pace of which innovation happens,
yeah,
basically by doing that.
right.
And before you know it, they started coming out with, I think, I'm not sure of the numbers. It's either two products with three different versions to each, or it's three products with two different versions every 6 months. They got to that
Amazing.
pace.
That's
And
amazing.
yeah, and that's crazy. That's
Yeah,
amazing.
it's hard
And
to keep
look
up.
what they're doing. Yeah, it's hard to keep up. It's almost impossible. And look at what
Yeah,
they're doing with AI chips.
yeah,
They're putting
absolutely.
them out really, really fast. And it's all
Right,
based off
right.
using the digital twin, using the
Yeah,
digital twin.
that's amazing. Yeah, when we thought about digital twins in factories, I almost thought of like what is it, the Russian doll that has you take it, keep it apart, and there's the little one and then the bigger one hiding inside it or whatever. Anyway,
Oh, the egg. Yeah,
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 the
yeah.
egg kind of thing.
Yeah, yeah.
Yeah. And so it's like, okay, on an assembly line in a factory, I have a digital twin of every industrial robot and everything about it. But then I was like, but you know what? It has complex subsystems in each of those robots, and maybe that subsystem might deserve its own digital twin. It's so complex. Like the engine of your car might deserve its own digital twin because it has so many properties and so many things going on.
Okay.
And then there's a parent-child relationship, like between the engine in your car and the whole
Gotcha.
car. And how did that
Right.
map? And so we
Gotcha.
would do,
Gotcha.
yeah, and so we do that with industrial robots subsystems, and then you'd say, well, okay, I've got all these robots and they're on an assembly line. Should I just say, and this goes to what you're talking about network effects, should I just say this is just a group? Or should I say, what if I make the whole thing a digital twin? All the robots together and the
Mhm.
assembly line are comprise a digital twin in that egg thing. And
Right.
so, I might have 10 robots, but they all work together and they all bubble up to something that we call an assembly line. And the success and the health of the assembly line there's a mapping to each one of the robots. And then you could go further and say, and then I've got 5 assembly lines all together, and we put that together, and it's a digital twin of a factory, things like that. Smart cities. I've got the perimeter of a city like Houston.
Right,
You've got
right,
streets and
right,
rivers and whatever and
right. Lights and
lights.
roads and
Exactly. You've got
yeah.
roads. You've got things you can't see. The underground, the whole city is complex. The water systems, the pipes and everything
Hmm,
for
hmm,
water
hmm.
and sewage, electricity, fiber optics, and then buildings. And I remember I spent some time with this startup a while back that was doing, we were doing smart buildings. And it was just like, okay, there's a property. Someone might own a property. It could be like it doesn't just mean the property doesn't always just mean it's the building. It could be like a campus that may have one or more buildings on a property. And so the big part of the twin is that, and then you zoom in to one or more buildings, and then each building has one or more floors, and then each floor has one or more offices, closets, whatever. And then all the IoT sensors and stuff are living inside all those places. And that real-time data coming in there brings that building to life. And so now it's a living building and not just some dumb static thing, right?
Yeah.
And that's kind of how is, I mean, building a smart city is hard, no
Oh
doubt
yeah.
about
Oh
it.
yeah.
There's a
I mean,
lot
you
going
got
on.
to some kind of momentum has to happen for things to start connecting and networking together somehow.
Yeah, yeah. No, you're right. I love what you're talking about, though. The how in a home, and it's about the person, and it's personal, and it's about their life, how it changes over the years,
Hmm.
and
Right.
what do they need, and how do their needs change as they
Right.
get
Think
married?
about all the way from an infant. An infant,
Yeah,
they have these modern monitoring clothes,
yeah,
these outfits
yeah,
that
right.
all the way to, senior living,
Yeah. Yes,
right?
I had a friend from Microsoft, and when he left, he went and did a startup, and it was about seniors. It was that whole that term aging in place, where people
Hmm.
like, I don't want to leave my home when I'm really old and go
Correct.
to some
Yeah,
old
I don't want to
storage.
go to a senior home or something
Yeah,
like that. They
I
want to
want to
stay
stay
at
here.
home. They want to stay at
And
home. Yeah.
the whole is, what could I do with IoT so that I could stay in my home? And there's so many things you could do.
Many. Correct. Correct.
Yeah. And
Yeah.
I just think in general, just what you said though, just how you approach the home and the life from infant to growing up to growing old, man, there's got to be so many different use cases and
Hmm.
scenarios that
When you
could
think
add
about it, yeah.
value.
Yeah.
Huge. It's huge.
When you think about it, yeah.
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 And you just have to put your head down and go, okay, let's think through all this. What
Right.
are the things that make my life better at all these different stages of life?
See,
I
and
think
and
that
that
could be,
would that right, and that would cause things to start connecting,
yeah,
right?
yeah,
That, and then before you know it, the numbers start compounding of things connecting, data,
right.
obviously,
Yeah,
data, like, you
yeah,
know, and then, well, what do you do with that data?
right.
Okay, well, it can feed AI, right?
Yeah, right,
Okay,
right.
well, what would you do with AI that has that kind of capability, with the concepts of LLMs, but then you have this data of people interacting with the machines that they use, in so many different scenarios. And then you have the data of the M2Ms, precision, precise,
Yeah,
accurate,
right.
uh, sensors, think of, okay, the way we interact with the world and we learn the world. How do we
Yeah,
learn it? Through our five senses,
yeah,
right? How
right.
many sensors can you have in IoT? Like,
Lots.
you know, visual on different visual spectrums,
Yeah,
infrared,
yeah,
all this, night vision, all this,
right.
sounds, all this.
Yeah,
Now when you start getting that momentum going of
yeah,
these things starting connecting for people,
yeah.
you know, that's that's
Right.
the big data what people talk about when they
Yeah.
talk about IoT,
And it
right?
bleeds over into
And
their
yeah, and
well-being, their
it's
health care,
correct,
you
correct,
know?
correct. Yeah. I think now what they're talking about with you know, AI is, I know it's still evolving with
Yeah,
LMMs, but uh they're from when AI started, it hit like a U curve of learning, like, because of the data of the internet. It hit this
yeah,
U curve. But the learning after I think Model 3 or Model 4, it started just
yeah,
leveling off.
Yeah,
right?
it's been more incremental
Right? Because
lately.
of the data. They're running out of data to use, or the
Yeah,
different various types of data to use, right? So the learning curve, I mean, it's still learning. They're making them
yeah,
better, they're making them more efficient, stuff like that. So I know the whole big topic was about, oh, AGI, we're almost there at AGI,
right.
everybody be scared,
Yeah.
and I'm like, we're not even close to that. And so when now some people are talking about, well, let's start building AI off of real world models. That's kind of people what they're talking about, real world models of AI. And that
Right.
this I forgot who the guy that did the folding
Oh, the protein folding?
yeah, the protein fold. I think he was the one that was talking about real world models. It was either
Yes.
him or the guy that's in charge of the Google AI. They were talking
Okay.
about real world models now. We're
Well,
going
I
to try
did.
to.
There was the guy, his last name's a French guy, LeCun, Jan LeCun, and he was the head of AI at Meta at Facebook.
Hmm.
He
Hmm.
left
Hmm.
recently, and he had said, "We are not going to get to AGI with this,
Hmm.
what we're doing here. We need to go out to the real world and have real world models and analog and the whole thing." And he was talking about IoT data.
Exactly. That's the first thing I thought about.
Yeah,
What's the best way to build a real world model?
yeah,
IoT.
it is. And all of a sudden,
IoT.
IoT's back, baby.
But yeah, I mean, that's the way I was thinking. I was like, yeah, real world model. The
Yeah,
best way to represent a real world model is IoT. You have all these sensors, all these products,
yeah,
then you have people interacting through all this. That's data, infinite
right,
data coming in,
right,
real time, real
absolutely.
time.
Yeah, no, you're
So,
so right. I did think it was interesting, speaking about getting to AGI. So the guy, was it Demi, whatever, he's the
hmm.
CEO at
Hmm.
Google DeepMind. He said
Right.
something really interesting, which is really funny because he's the head of this thing for Google, and yet he goes, if our best model comes out and it has all its capabilities, but we don't give it any data or any knowledge after 1905, let's say, and let's
That's
see
all it
if and
knows.
let's see if it can come up with
Yeah.
a theory of relativity and invent atomic stuff.
Right.
If it
Yep.
can do that, then it's truly AGI. But if not, it's just a pattern matching system.
Correct. Exactly.
Yeah.
I
I think
think I
he's
saw
right.
that quote too. Yeah.
Yeah.
I think I
Yeah.
saw that quote too. Yeah. Yeah. Yeah.
Yeah.
Yeah.
I think he's right because right now, I mean, I think AI is helpful and it's does some great stuff, but yeah, is it really, before the whole transformer thing came out and DeepMind
Hmm.
started doing that and everything, just the machine learning, there were still lots of great breakthroughs with people using TensorFlow and stuff like that and detecting early breast cancers and all kinds of things. And this was before the transformer and this generative
Right.
stuff. Yeah.
That's how I got started researching AI because, like, as I'm doing the research of the smart home and then IoT industrial, I'm like, the subject matter of AI comes into. You
Yeah.
just come across something, just
Yeah.
like what you're saying. Those little things you come across, and you're like, well, that's not in my mind. I'm like, that's not what I'm really talking about right now. And then, the whole when ChatGPT came out and that whole AI explosion, I'm like, okay, let me start researching and see how this fits together,
Yeah.
you know? And
Yeah.
then I recall back to the book, The Platform Revolution, where they talked about the history of the internet and what happened and then all that data,
Yeah.
right? It's like I remember sending you a link to a podcast about hyperscaling and the whole history of like data centers and how
Sure.
all that came back to be. And it goes like way further back, all the way till now. And it goes into all the details, like the internet, the backbone,
Yeah.
all
Right.
the fiber cables ran
Yeah.
across the world.
That's
What
right.
happened? They overbuilt in anticipation of the internet, right?
Yes.
Companies failed, but the internet took off, even though these fiber cables were laid out because that backbone was already built.
Right.
You
Right.
know, it can sustain the growth at
Yeah.
at a
Yeah.
exponential
No, you're
growth.
right. All those companies, many of them that helped build that infrastructure, all that fiber they laid and everything like that. Yeah, a lot of them went out of business, and so we had this dark fiber, as they called it,
Right.
everywhere, not being used. But eventually, we used all of it, and we needed more. Um,
Right.
yeah,
We needed more. Yeah.
the failure, the whole dot-com bust. I know it's I remember because I was part of it, and it's painful when it happens to you. But there's that notion that, yeah, a lot of people are going to fail, but the things we did then are going to keep on going and lead us to this bigger future. It wasn't all for nothing. It wasn't a waste of time. Even
Oh, yeah.
like when you talk about the ones who made it through, like Amazon, they had tough times too. A lot of them were like really
Right.
hunkered down when things crashed, and they're barely making it. But they, like Steve Jobs said, that what separates successful people or businesses from unsuccessful is the successful ones, they just won't quit. They won't give up. They just like, I'm just going to keep at it. Maybe stubborn.
Right.
I
Right.
don't know. Um,
Yeah.
but yeah. And so is there the analogy for today is, are we overbuilding data centers for AI? And will a lot of these
We're
companies
building the
go out of
foundation
business?
structure.
What,
Even
build
if
all
they
these
go out of
data centers?
structure,
Yeah.
we're there's no we already opened the Pandora box to AI. There's no way, you know, even if Chat GPT fails and I mean OpenAI and Claude they fail, there'll be another company to fill that to try. It's a
Yeah.
race to get to AGI.
Yeah. Yeah.
That's the whole. There will always. It's that's not going away.
You're right.
And then we'll have the foundation of these data
Yeah.
centers in place, and maybe it repeats.
Right.
You know,
Yeah. I think
it's
you
just
might be
figuring
right.
out how to do it. We're in the
Yeah.
process of figuring out how to do it.
That's so true.
So
That's so true.
yeah,
Oh my gosh. This is crazy stuff, man. It's good discussion.
yeah. Real quick.
Yeah.
I what gets confusing a lot. How do you define IoT? The definition.
Mm,
That's like when you get into those, you come across people and they define it each differently. And
yeah.
the way I think of it, like I put in the writing, um, I just keep it simple. Like it, when you're talking about what the market, the whole size of the market is, you just define it as two networking scenarios. People networking with machines forward and backwards, and machines networking with each other forward and backwards. That's the market. That's what IoT is.
Yeah.
What
Yeah.
people talk about is all the technology, right?
Right.
See, all the technology is there to support those two networking scenarios.
Yeah.
And then all the markets of IoT are built on top of those new two networking scenarios.
Yeah.
So what you're trying to do is get these scenarios to scale,
Yeah. Right.
right?
Right.
That's what you're trying to do with IoT.
Yeah. I mean, IoT was just a shorthand or some way to describe a collection of enabling technologies. Like
Right,
people, sometimes I don't know, I'll be weird about it. Some people are like, oh, the IoT industry. And I'm like, what's the IoT industry? There's the
right.
automotive industry and there's the whatever construction industry and all these. And IoT is a collection of enabling technologies that helps you to solve problems. And you're right, it's devices and sensors and it's networks and it's data and it's databases and it's a whole bunch of
Mhm.
stuff.
Right. It is. Yeah, yeah. It
And
confuses
it's
you. It's like this is what when I first saw the term IoT, I was like, wait, it's everything you just said. It's this, and that. Well, I'm like, well, what is it actually? What
yeah,
is it? And then you learn like, okay, well, there's individual markets that fit into the concept of IoT.
yeah,
What is that? You know, it's like,
right. But to your point, it's back to your book you read, platforms. And the internet became a platform. The internet came about and people started building web pages and websites and
right,
e-commerce. And
right,
it
right,
was a
right.
platform on servers and web servers, and the internet made it all possible. Remember Sun Microsystems was so big in the 90s, and their motto was the network is the computer, which I thought was really interesting.
Okay,
That was like their tagline for Sun Microsystems.
right,
You know,
right.
now sadly, I do remember I used to go, when they came out with Java, kind of in the mid 90s, and then Java was starting to get popular in the late 90s and things like that. And then there's the dot com. And, during the dot com age, all those venture capitalists in Silicon Valley, they would give the company however many millions of dollars, and then they'd say, and I need you to take this many million, you have to go buy servers from Sun Microsystems because that's the only way you can do the internet and do websites. And then that turned out to not be the case over
Yeah, it's like a
time.
closed ecosystem or something.
Well, also, Sun was making a fortune off of this because they're selling like $1 million servers. And then there's this little Linux thing that was free running on
Oh, yeah, yeah, yeah. Okay.
commodity PCs. And some people were doing Windows Server. And I remember I'd go to that Java One conference in the late 90s through the early 2000s. They always have it in San Francisco. And so their CEO, Scott McNealy, would always do the keynote. And I remember after the dot-com bust and it was over and Sun Microsystems was in bad shape. They were about to die.
Right.
And I remember he came on stage and he looked like dejected and he said, sometimes good enough is good enough. And what he meant was it turns out those cheap Linux boxes were good enough to make the internet work and have nodes
Right.
on the internet. You didn't have to buy $1 million server from us. And
Yeah.
and that was a lesson, we always want to do the best thing. I get it, and you want perfection, but sometimes good enough is good enough, you know?
Yeah.
And so,
Well, I'll close out
yeah,
with you like so it made me lose my train of thought. But I was gonna say what a lot of the when you're talking about the Linux thing, um, I think when they talk about like platforms in that network of the platform book,
yeah,
they talk a lot about reducing the complexity or get trying to reduce the friction to the market.
yeah,
That's how you create the initial value
right.
to where you start attracting. So it's kind of like that with
Yeah,
Linux, it was what cheaper,
yeah,
simpler or whatever, more open.
yeah.
So
It was
that's how
free.
you supplant markets. Right. It's free.
It's open
Right.
source, it was free, and it turns out it was good enough. And it
Right.
got better.
Right.
But back then, even then, it was good enough, you know?
Right.
Gosh, I remember being at Microsoft my whole career. I remember when Steve Ballmer called Linux a cancer.
Oh, okay.
Yeah. Yeah. He's like, we got to kill it because it threatens Windows, right?
Right. 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 Right.
Yeah. Yeah,
So
absolutely. Oh my gosh. Well, this is good stuff, man. We'll have
yeah,
to,
definitely. It's just good to meet you, man. It's good to talk.
absolutely.
So
We'll have to keep doing this and we'll have to have you come on coffee talk with everybody else, you know?
I don't know if anybody's gonna agree with me.
No, but that's
Um,
okay. Because I don't know that any
yeah,
of us is right. We just have a
I,
different opinion.
yeah, you're
And
correct.
maybe it could be that we are all wrong all this time and you're the one who's right. And that's fine. You know?
Okay.
You know?
We can leave with that. That's good.
I love it. I love it. Oh my
Okay,
gosh.
man.
Well, it's
It's
good
good to
hanging out
talk.
with
We'll
you.
talk again
We will do
next
it.
time.
All right. Take it easy. Thanks for coming on here, man. This is great.
All right, same here.